All right, in Chapter 8, we're going to look at reviewing some of the basics from geometry and apply those to some everyday situations where geometry could be applicable. So we'll start by reviewing some of the basics of geometry and parallel lines, move on to reviewing some trig and seeing how those can work. So parallel lines are coplanar lines that do not intersect. So coplanar just means they're in the same plane and they don't meet. So for example, in this line, line PQ, if you recall, we put the little line above it to make it a line, is parallel to line RS. So those are parallel. PQ and RS do not meet. Now PR and PQ meet obviously at P. So parallel planes, same thing. So a plane is a flat surface. So parallel planes are simply going to be planes that do not intersect. So planes, and when you get into three-dimensional plane, can be a little trickier, but we'll just say the floor and the ceiling for a typical room are parallel. Now skew lines are kind of the weird thing. So skew lines are lines that do not intersect, so they don't meet, and they're not coplanar. So they're lines that they don't meet, but they're not necessarily on the same plane. So an example would be if I have a room, let's say I have this line going this way, and then I have a ceiling up here, a top plane, and I have a line going this way. Now those don't meet, although if I looked from the top, it would look like they meet, but because they're on different planes that are parallel, they definitely will not meet. So parallel lines are important because if you recall from geometry, the reason we're really looking at this is because you have lots of relationships where angles are similar that we'll talk about here in a second. So here's a quick example. We want to name all the planes that are parallel to A, E, F. So A to E to F would be this side here because that's the plane that contains those three letters. So there's only really one plane that is parallel to that. That would be GBC, because GBC would be this plane over here. So if you have a box, the only side that's parallel doesn't meet the left side, is the right side. B says name all the segments that intersect AF. So here's AF here. So there's lots of them. So let's see. So there's this one and this one and this one. Then don't forget this invisible line back here in the box also intersects AF. So that's I can't see what this letter is, AB. And then FG. And if you just want to put the segment bar over it, that's fine. AD and FE. All right, so I'm going to erase this so we can kind of start fresh because there's a lot of stuff going on here. Name all the segments that are parallel to DC. So here's DC. So EH is parallel, FG is parallel, and AB are parallel. None of those are going to ever meet those. Every other one will intersect at some point. So we have AB, FG, and EH. Now the last one says name all the segments that are skew to AD. Now skew means they're not parallel essentially. So here's AD. So what are all the lines that are skew? So skew is not parallel, but not on the same plane. So the only one I think is skew is this one. So those won't meet because they're on different planes. Every other one, I believe, will meet. Nope, there's one more. You can have GB, and you could also have CH. So those would all be skew to that one. Now it can't be FE because those are on the same plane. Could also be EH. So I'm trying to think of all the ones that would not meet it. That would be segments. So we have GB, EH, EC, it's a different plane, and CH. Now, skew lines we don't use a whole lot, to be quite honest, but it is kind of just a good idea to kind of start looking at how these shapes work and how these sides are related. Now, what we're really looking for is we're going to start talking about transversals. So a lot of times when you have parallel lines, or if you have any lines in general, if you have a third line that crosses it, then we call this a transversal. Now you can see this a lot. So if you have, say, if you have like a tabletop or something like this, and you have a leg, sometimes you have legs that come off like this, then you're actually creating transversal lines through other lines, and you're making a ton of angles. So you can see angles, 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 angles. There's all these angles in these shapes when you start doing these lines with lines crossing it, and so that's why we're going to start looking at these angle pairs. Now, exterior angles are really any angles on the outside of the two lines. So if I think of these as my lines, Q and R, they might be parallel, they might not, doesn't really matter. When they're parallel, obviously more important stuff happens. So we'll say P is the transversal because it basically goes across the other two lines. So exterior angles are going to be anything on the outside of these two lines, Q and R. So 1 and 2, 8 and 7 are all exterior angles because you can kind of consider all of this the exterior, and then the interior is going to just be this little region. So the interior angles will be 4, 3, 5, and 6. Now, we have names for all these different ones. So consecutive interior angles sometimes are also referred to as same side interior angles. So those are going to be 4 and 5, 3 and 6. So 4 and 5 are a set of consecutive, and so are 3 and 6. Now, if the lines are parallel, they have a special property. If they're not, doesn't really matter. Alternate and exterior angles are going to be exterior angles, so they're going to come from our top list that alternate. So they're going to be on opposite sides of this transversal line. So you could say 1 and 7 are transversals, and then maybe 2 and 8. Alternate interior angles obviously have to be interior angles, and instead of being consecutive or same side, they switch over these. So 5 and 3 are a pair, and so are 4 and 6. Now, corresponding are the kind of different ones because they're the only ones that are going to have one interior and one exterior generally. So they're just in the same location. So 1 here would be in the same location as 5 because they're in relation to the transversal, they're up and left. So you could say 1 and 5, 2 and 6, 4 and 8, and 3 and 7. Okay, so this nice transversal line makes all these angle pairs, and then if you know one angle, you can figure out a lot of the other ones. So the transversal line is a line that's going to intersect two or more lines at different points. So in this example, it says identify the pairs of lines to which each line is transversal. So it says line P. So if I see line P here, it has to intersect two or more lines. Well, it definitely intersects line T. What other line would it intersect? Well, if you take R out, it would hit R, and it would also hit Q, because Q would come out here and it would intersect, and R would come out there. So any line it hits, because remember, lines go infinitely long. Even though if it says it stops here, it keeps going. So R, same thing. R will intersect Q. It will intersect T. And it will also intersect P. So if you look at these, they're all transversals of one another because none of these appear to be parallel. So for Q, Q will intersect P at some point. Q will intersect R. You can see that on the paper or on the example, and T. And then T, same thing. T will intersect all the other ones, so P, Q, and R. Now, if they start to be parallel and things like that, then it doesn't have to intersect all the other ones in some diagram, but in this one, it looks like all of them. Now, the cool thing is when you start talking about parallel lines cut by a transversal, then we can talk a lot about some different angle relationships. So the corresponding angle says if you have parallel lines, so if you have two parallel lines that are cut by a transversal, then corresponding angles is congruent. And if you remember what congruent means, that basically means the same measure. So we'll start using that word again, congruency, where things are the same, things are not. Alternate interior angles, same thing. If you have alternate interior angles, they are also congruent. They're the same. And alternate exteriors are also the same. So we start to get a lot of these things that are the same. Now, consecutive interior angles, these are the ones that are on the same side of the transversal. They don't alternate. They are not the same. They are what we call supplementary. Now, supplementary, if you recall, means it adds to 180. So the two angles that are same side interior angles add to 180. So the most important thing here is you have to have a set of parallel lines. If you have a set of parallel lines, then all these things apply. So let's look at an example of how this works. So in this example, measure of angle 3 is 110. So that's fine. So this is 110 degrees. And 12 is 55. Now, if you notice here, we have parallel lines. This is the most important thing. So we have parallel lines here, and we actually have two transversals. The nice thing is you really only need one angle to find these four and one angle to find these four, because we can kind of use the idea of alternate interior, alternate exterior, same side interior, all that stuff to find them. So if I start on the green ones I have here, well, I know 3 and 1 are consecutive or corresponding angles, so I know this has to be 110. I know 6 and 3 are alternate interior angles, so this has to be 110. And I know 1 and 8 are alternate exterior angles, so these have to be 110. So just using those theorems, I found 4 angles right away. These being alternate exterior, these being alternate interior, and these being corresponding. Now, the other ones we have to find, so we still have to find 2, 5, 4, and 7, and not surprisingly, they're going to be the same. Well, if I look at these two consecutive angles, I know they have to be supplementary. So 180 minus 110 will be 70. So this angle will be 70, so will this one, so will this one, so will this one. So when you have parallel lines, and obviously lots of objects and things that we'll see will have parallel lines, you could have all these angle pairs being the same. Same idea here. If 55 is there, we know 10 is 55 because it corresponds. Then I know 15 is 55 because of alternate interior. And then 55, and this 13 would have to be 55 because of alternate exterior. Then for the rest, we'll just do 180 minus 55, which is 125. So the rest of these should be 125. 125, 125, 125, 125. So now that I have them all, I could just come over and fill out this chart. I really didn't even need to do this because I literally found them all. So that's 110, that's 70. 13 turned out to be 55. 6 turned out to be 110. 10 turned out to be 55. And 15 turned out to be, where's 15? 55. So, I found them all. I didn't have to, but just as easy to find them all as it is to find one. Now we can also do this to do some algebraic expressions. So in this first example, you see we have parallel lines. We want to find x and y in the following figure. Well, you notice these both have y, but this one has an x. So first I'll look at the y's. Well, the things with the y's, these are both interior angles and they are consecutive. They're not alternate interior. So they don't switch over our transversal. This is our transversal. They're on the same side of that line. So same side, consecutive interior are supplementary. So we know these two things together have to equal 180. So this is kind of what we'd have to solve. So 8y and 25y is 33y. Minus 18 equals 180. So then I'll just solve. So I'll add 18 to both sides. So I'll get 198. And then I'll divide by 33. So I'm hoping that 198 divided by 33 is nice, and it is, so y is 6. Now, to find x, we'll have a little bit of issue, so what we're going to have to do is be a little slick about it. Well, I know this 10x and this 25y minus 20 are the same because they're alternate interiors. So I know 10x equals 25y minus 20, which might seem pretty troublesome because now we have two variables, but we know y is 6. So I can just put the 6 in there. So 10x equals 25 times 6, which is 150 minus 20. So 10x equals 130. And then I can simply divide by 10. So x is 13. Now this next one looks very different. It looks just like a trapezoid, but you can see it has these two parallel lines. If I extend them, these really are parallel sides, so parallel lines. And then I have these transversals that cut through them. So this one, for example, is one transversal. And these two angles are consecutive interior angles, so we know those are supplementary. So I know that equation. I can add those two angles together. 3y plus 18 plus 90, and that has to equal 180. And that will allow me to solve for y. So 3y plus 108 equals 180. I'll subtract 108 from both sides. So I'll get 72. And then I'll just divide out by 3. So dividing by 3 is going to give me a y of 24. Now, unlike the previous problem where we had to use y to find x, in this case I don't think we do, because you can just look here that we have a new transversal, which is kind of this side of the diagram, and we have two other consecutive interior angles. So we have 15x plus 30 plus 10x equals 180, same idea. So we have 25x, because we have two x terms, plus 30 equals 180. Subtract the 30, so 180 minus 30 is 150. And then I'll just simply divide by 25 on both sides, so x is 6. So these were both, it really comes to look at, are they the same or are they supplementary if you have parallel lines cut by a transversal? Now this last one's kind of an interesting one because we don't really have a true transversal. We kind of have two parallel lines, obviously, and then we have these angles just kind of sitting there. So let's go ahead and see how we could deal with this one. What I would probably do is I would probably extend this line like this. And so now I have a parallel line with this transversal, we'll call it T. So why this helps me is I know this is 36, so alternate interior would be here, so this would be 36. And now this is kind of a problem we did last chapter where we have this triangle and we have an exterior angle to that triangle. So if you remember, an exterior angle is equal to the sum of the two remote interior. Now, the two remote interior would simply be the 36 and 31. So the measure of angle 1 is simply going to be 36 plus 31. So that's 67. So in this case, you not only had to know your parallel theorems with the ultra interior and all that stuff, but you had to go back and we had to remember the exterior angle theorem to solve this one. So just some basics on how to find angles, and we'll see how we can apply those in the near future.